Hello everyone and welcome to Longevity Article Review number 8. My name is Jordan Marsh and I'm happy to be back. I actually just turned in my application for residency this week, and the weeks prior to that were pretty busy getting that ready. So I haven't been able to do these reviews as much as I'd like, but I'm excited to be able to do that now. Today we're going to talk about, again, cold water immersion. This is part 2 of what we talked about in LAR number 7, and I'm excited to talk a little bit more about anabolic signaling as opposed to just changes in muscle mass and strength, and that's what part 2 of this study does. All right, so let's get into it. As for some bird nerd time, as always, this is the emerald toucanet. This is a close cousin of the more popular toucan. It's actually half the size of a toucan, which I thought was kind of interesting. I think that's just a beautiful bird. I also found an interesting fact about them was that during their mating ritual between males and females, they often will pass like a berry or a nut between each other. I don't know necessarily what that's for, but I thought that was pretty cool. So check out the emerald toucanet. I think that's a really pretty bird. So here is what this study was. This was a randomized crossover study, which you might wonder, what is that? Well, a randomized crossover study is just this. Each patient receives both treatments. So as you can see here, there's a blue man on top and a red man on bottom. The blue man receives a specific treatment, and the red one also receives a different treatment. And then after a certain washout period, which is technically just a period of time, they both go and receive the same treatment, just in reverse, okay? So we had 10 participants that all did this, that all went through different, they both received both treatments. They're physically active young men, and they did 2 bouts of single leg strength exercise on different days. So basically what this is we're gonna go do single leg exercise, and we're going to really work the single leg out hard, and then we're gonna either do cold water immersion after that, or we're gonna do active recovery after that. And then we're gonna wait a period of time. I don't know exactly how long they waited. My guess is around a week, maybe 5 to 7 days. But then we're going to do the same type of exercises, and then we're going to do the opposite. So if we did cold water immersion last time, we're going to do active recovery this time, okay? So that's what this says. Each session was followed by cold water immersion, or ACT, active recovery. And then we collected muscle biopsies from the vastus lateralis before and after each session. And we did that at actually different increments afterwards. So we did a muscle biopsy before, we did one 2 hours after our exercise, 24 hours after our exercise, and then 48 hours after our exercise. And remember, we are doing both active recovery or cold water immersion immediately after exercise. So, it should give us an idea at 2 hours, 24 hours, and 48 hours exactly what the anabolic signaling is like in the cells that we're collecting. All right, and then care was taken to insert the needle in different directions at each of these different intervals. Okay, so I showed you this table in LAR number 7. Let me just do a little highlighting to show you exactly what we did. This was all LAR number 7 up here, but now we're going to be doing study 2. And these are the exact exercises that they did. So they did a 45-degree leg press, a single leg squat, knee extensions, and walking lunges. And they, in their repetitions in order, were an 8-rep max, an 8-rep max, a 10-rep max, a 12-rep max, and so on and so forth. And we just did that. We completed these single leg exercises, and then we underwent either cold water immersion or active recovery, and then did our muscle biopsies to see what was happening inside the cells. Okay, so this might get a little, I don't want you to get lost here. These are going to be somewhat complex, but I think I know how to explain this in a way that should make sense to you going forward. Okay, so here's the results. What we're looking at, just on a high level, we're looking at both satellite cells, which I'll tell you about a little bit later. This is not satellite cells. We're looking at proteins in the mTOR pathway, okay? And whether those proteins were phosphorylated or not. So if these proteins, what does it mean to be phosphorylated? Phosphorylated just means that there's a phosphate group attached to this protein. And when a phosphate group is attached to this protein, it's essentially activated. And when that protein is activated, it serves to increase cell growth, okay? So again, what are we really looking at here? We're looking at we're wondering whether cold water immersion is attenuating or slowing down cellular growth and making it less likely that we're actually going to see muscle hypertrophy or increases in muscle strength, which I showed you in LAR number 7. Okay, so all you have to really know is just that if something is phosphorylated, it's activated, and when it's activated, it has a chance to increase our cellular growth. All right, and that's what's happening here in figure 4. So there is a protein, different versions of the protein I'll show up here, but it's P70S6K. And then we're looking for phosphorylation on certain amino acid residues, which is just at certain locations on the protein. Okay, so if the phosphorylation happens at a certain location on the protein, we know that it has been activated and it is working its way towards making the cell grow. All right, so down here on the bottom, this is called a Western blot. Down here on the bottom is kind of like a control. It's a GAPDH that just says we've put the same amount of sample in our little well here, and we're going to see if we see that. We're going to see that sample grow. We're going to see if that sample shows phosphorylation. And basically, the best way to look at this is just to say, if it's darker, then it's more phosphorylated and it's more activated. And if it's lighter, then it's less phosphorylated and less activated. I also should mention here, there's kind of a dividing line here and here, okay? So as you can see in the graphs down here, there's an A, B, and C, and I'm going to kind of correlate that with what we see here. So A, B, and C are separated by these lines in our Western blot, and in our graph, we're looking for the fold change, or how much phosphorylation occurred at different time intervals for different groups. So as you can see here on the x-axis, we have our pre-exercise biopsy. Then we have our 2-hour biopsy, our 24-hour biopsy, and our 48-hour biopsy. And then we're measuring all of these different proteins and how much they changed during that time. So, you might expect that change to be large if we've really worked out hard and we've told ourselves, hey, you need to phosphorylate those proteins that activate growth so that we can grow. We need to grow in order to handle all this exercise that we're doing. Okay, so as you can see, I don't know if you remember from LAR number 7, and if you don't, that's obviously fine. You may or may not have watched it, but the nomenclature that they're using for this is the stars represent a statistically significant change compared to the pre-testing biopsy, okay? And then the number sign represents a statistically significant change between groups. So I'll just say between groups. I am sorry for that poor handwriting. That is just it's been a while, so I'm going to try and get better at that. But so as you know, we're comparing what the biopsy looks like based off of what happened in our pre-biopsy, and then we're also going to compare it between the active recovery and the cold water immersion group at each time point. Okay, so if you look at this, you can tell very interestingly that let's just start with A up here. So this is the graph for A that shows the phosphorylation fold change in both the active recovery and cold water immersion groups. As you can see, let's start with the white group. The white statistically significantly changes quite a bit at just 2 hours post-exercise in the active recovery group. And it also does it at 24 hours, so here and here. But also, between groups, it shows that the active recovery group has more phosphorylation than the cold water immersion group. So that's what this number sign is telling us. So we know at both 2 hours and 24 hours with active recovery, we're going to get a much larger increase in phosphorylation of this particular protein. And it's going to be better than what it was before the biopsy, and it's also going to be better than the cold water immersion group, okay? The cold water immersion group still sees at least a change here between its pre-biopsy value and its value at 2 hours, but it's still much less than that of active recovery, which is kind of what you'd expect after what I did in LAR number 7, and is something that's interesting, okay? Again, you see that here. You don't necessarily see differences between groups, but you see an increase in the fold change of this particular protein and its phosphorylation in both active recovery and in cold water immersion, but that does not hold up at 24 hours, and it does not hold up at 48 hours either. And again, here, the same thing, no significant change until we get to this point. At 48 hours after our exercise, we see an increase in both the pre-biopsy and the between group value. So what does this say? I mean, I'm not going to go into too much depth about what this protein is and what it does. All you have to know is that if it's phosphorylated, it is increasing growth. And it's pretty clear, again, that with the active recovery group, we are seeing a larger increase in this protein that causes growth. And in the cold water, something about cold water immersion is dampening the phosphorylation of this protein. And that is something to be noted, okay? So I took a lot of time on this one. I hope I don't have to take as much time on these later ones because it's kind of the same idea, okay? So again, we have an A, B, and C group, and we're just comparing the fold change in these different ERK1 and ERK2 proteins. And it's interesting in this one because what you might expect, like I've kind of been leading you to believe, that maybe active recovery is the best way to increase muscle growth. In this particular protein, that's not what we saw. So the cold water immersion group actually had a statistically significant difference between pre and 2-hour biopsy. And the cold water immersion group again did that at the 24 hours, and there was no difference with active recovery. So honestly, this is the one that's kind of an outlier versus everything else that I'm about to show you. But I thought that was interesting. And okay, so here, this one is actually another protein in the pathway. You definitely don't see too much of a difference here, except for these values here in group C. But there is a between group difference in both the 24-hour and the 48-hour biopsy of this particular protein, RPS6, which shows again that that the phosphorylation of that RPS6 was much larger in the active recovery group than it was in the cold water immersion group. Okay, and then this one is really cool. Okay, I need to talk about what satellite cells are. So satellite cells are basically, they're kind of like stem cells in that they just kind of hang out around muscle protein. They hang out around muscle cells, and they jump into action when there's an increase in stress in the cell, likely induced by something like muscle strength training, okay? And these cells play a critical role in supporting the growth and supporting the repair of these cells after they've been damaged and stressed by exercise strength training, okay? And so PAX7 is one, and NCAM plus is another one. And there as you can see, kind of similarly, from what we've seen in the past graphs, again, there's a statistically significant increase in these in the active recovery group at both 24 and 48 hours. And there are differences between groups. So again, showing something about cold water immersion is dampening the effect of these satellite cells, at least PAX7, and you see that again in NCAM. So NCAM, there's all of these statistically significant differences. There's a difference here between groups, and still, however, there is an increase at 48 hours in cold water immersion for NCAM, but you might expect there's still less than what you get from active recovery. Okay. And so as you kind of think about this kind of makes sense as it relates to what we saw in both the increase in muscle mass and the increase in muscle strength in LAR number 7. Except in this time, we're looking specifically at cellular markers of muscle hypertrophy. And, as you might expect, those are going, with cold water immersion, we are dampening the effect of these anabolic signals. And with active recovery, we are allowing them to flourish, or we are allowing them to do their job and help our muscles recover better. All right. So here's 3 good things about this study that I think is helpful to know. This comes directly from the authors. Cold water immersion delayed and or suppressed the activity of satellite cells and kinases in the mTOR pathway during recovery from strength exercise. We can see it both on a macro level and on a micro level. And this one was more about the micro level of changes that we see. of course, we can now deduce from that cold water immersion may be counterproductive to muscle adaptation. And we need to remember that when we're designing our strength training programs. And then from the authors, they said this investigation offers the strongest evidence to date that using cold water immersion on a regular basis may interfere with training adaptations. Okay, so if you like to jump into a cold plunge after your strength training and you feel like that's somehow, reducing your inflammation or helping your muscles repair better, you should probably think twice after seeing this study. And I think that's something that you should keep in mind, okay? Here's 3 things to consider. This is something I've been thinking about a lot, okay? So there is a documented effect on delayed onset muscle soreness with cold water immersion, okay? So we all likely have, tried to lift weights and maybe tried to lift a ton of weights. And when we did that, the next day we can barely even walk, right? And it's a painful sensation. It's not necessarily all that fun. And if you think about it, that might actually deter us from doing more strength training, okay? So if cold water immersion does delay onset, it does delay this onset of muscle soreness, perhaps that makes the exercise more enjoyable, right? Maybe we, really work hard on strengthening our muscles, and then a nice cold plunge at the end helps us feel alive. It helps us feel good. It also makes us not feel as sore, and then maybe it's more enjoyable to go back 2 days later and do it again, right? And I think that there's a balance there. There's a balance between making sure that your exercise is enjoyable so that you continue to do it, and also making sure that your exercise is actually efficient and is actually helping you achieve the goals that you have for yourself. And I think that there's this continuum there that varies for every person. Some people just like to punish themselves, and some people just have the hardest time even getting up at all, to do exercise at all. And so I think you have to just consider that when you think about the enjoyability of exercise, but also the efficiency of exercise, and how you want to, align your strength training program or your cardiovascular training program with, whether you want to just punish yourself and improve quickly, or if you want to really, work on something that can be more of a long-term exercise plan. So you have to think about that. And I have been thinking maybe if this study was done over a year-long period of time, and somebody was doing cold water immersion consistently, and maybe some people were doing active recovery consistently, maybe the active recovery would see more growth, but maybe they'd burn out faster, where the cold water immersion group might be able to maintain their strength training program for a longer period of time and still see improvement, So just something to consider. Something I've been thinking about a lot lately is just how do we design programs that don't burn us out, but also help us see results? And that's a delicate dance that I think we need to consider. The next are much smaller, but things again, this is a small cohort, only 10 subjects, and then again, they're only men, so might not be generalizable to more, other people in the population, okay? So those are my 3 things to consider, and that is LAR number 8. I'm happy to be back, and let's just keep the good times rolling. I'm going to try and do a lot more here going forward. All right.